Hey guys, what's up? Welcome back to the FordTechMakuloco channel. Today we're working on a 1998 Ford Econoline. And this thing was a government vehicle before, so it didn't move much and didn't get used that much. So that's about 30-some thousand miles on it. Literally the inside is so clean and nice in there for being this old. I mean, in 98, geez, that was forever ago. It still has like the new car smell inside. So it's pretty crazy. It's like a flashback to the past here. But the concern with this vehicle is the cluster. It's just all over the place on there. And come to think about making this video now, I had another vehicle in here, another Econoline, that was wigging out like this. This is like deja vu, sorry. Anyways, the speedo in the cluster just goes like this. So you put it in the drive, you don't even start moving yet, you can start the vehicle and it'd be like this, okay? So immediately you're thinking cluster. Well, the customer had to another shop, or he diagnosed it himself. He put in a new vehicle speed sensor in case it was failing, and he replaced the rear ABS sensor on here, which has nothing to do with vehicle speed on this particular model. So he replaced all the sensors already, and it's pretty crazy what I found on it. So I got it partially diagnosed on there. I want to go through and show you guys what I did to diagnose it, and then of course we're going to finish the diagnosis together and see what's actually happening here. What I really think was happening is the cluster is just bad. The little motor in there for the speedo is just bad, okay? And he immediately thought, without diagnosing it, we need the vehicle speed sensors, okay? And then when he put those on, he went aftermarket and he caused a whole host of new problems. So let's go through it right now. First off, let me show you what the customer brought in for. So basically what he's saying is that at any time really, the speedometer is just kind of really like twitching and just kind of all over the place and not reading correctly. So right now the key is off. You go turn the key on and it kind of like jumps like that. That's not normal at all. Sometimes when you start it, it'll do it. Okay. And then sometimes even when you just put it in the drive, like that, it does it. Okay. So what I'll do now is I'll let off the pedal, and we're just at idle right now, and I'll let the vehicle cruise. We're at idle right now, and it's just kind of all over the place and jumping around on there. Hitting the brake a little bit, slowing us down a little bit. And it's like twitching really bad. I let my foot off the brake. It's just kind of all over the place on there. So when we have an erratic VSS signal like this, you automatically think, let's go to the source. Let's go to the vehicle speed sensor signal itself. So I have the scan tool up here, and we'll see what's actually being reported to the scan tool on here. Gotta load up on there. So we're not moving at all right now, okay? And speedometer shows that. So let my foot off the brake and watch this. Moving a little bit, probably 5-10 miles an hour. And look at these spikes. They're all over the place. This is one erratic signal on here. I mean, this one right here says we're doing like 60 miles an hour. It's really dirty signal on there. It's coming out of there. But then you go to higher speeds, and it kind of planes out. I mean, it's a pretty clean signal right there, okay? But our speedometer is still way off. If this is truly coming in, 12, 13, it's pretty much smoothed out by now. Well, why is it still stuck at 40 something, just kind of doing anything it wants? So this leads me to believe that there's a cluster issue, and there's definitely a dirty signal issue at lower speeds on here. So let's go ahead and stop the vehicle. See, what comes back down to 0 across the board on here, which indicates there's no interference issues from the coils or alternator or short to power or something like that going on here. It's only when the vehicle speed sensor is actually being spun back there by the tail shaft. So let off again. There we go. Look at that. It's crazy. Now the other thing I noticed here, this is an older vehicle. It's 98 Econoline, E4OD transmission. It's an old transmission. And this is what I'm seeing here. These kind of are mirroring each other here. Well, this is the vehicle speed sensor signal, and this is the input shaft speed signal. Why are they basically mirroring each other? So I thought they were cross-shorted in there, causing an issue. But I found out is that this is an old E4OD, and there's not even an input shaft speed sensor on there. Not at all. So the software just kind of emulates it through the VSS on there. So this is perfectly normal for this old transmission on here. There's no sensor at all for the input shaft speed. So at this point we have an erratic speed signal, especially at lower speeds, from the VSS. So let's go down below, go to the source, and see what is going on here. Let's take a look underneath the vehicle here. So kind of get underneath here, this beast. And on the tail shaft of the transmission right here, nice out in the open, is the vehicle speed sensor. And you'll notice it's brand new. The customer replaced it, like I said, with a Napa Echelon unit here. And they were kind enough to keep the old Ford sensor that they replaced. That's the original one. So it's got a new sensor, so how is it so erratic on there? Well, let's go ahead and unbolt it and pull it out and see if the gear on there is chewed up, or the worm drive gear inside of here is actually loose and causing an erratic signal like that. So these are pretty simple. One bolt right there, and you have to pry up on these. They already broke one on the other side, so it comes right off. And we'll go ahead and unbolt it and check it out. All right, bolt out. Let's go ahead and wiggle it. And these ones you kind of just like twist and turn them, coming out and back in. And that's the way you spline them. So we'll pull it out, and it looks like they transferred the original speedometer gear, and these are calibrated based on your axle ratio, and etc. So they transferred it over to the new sensor. It's a brand new Napa sensor on here. It's not chewed up or anything. So let's take a look inside if I can get you to see inside. All right, now I'm going to take you up inside of the transmission through that vehicle speed sensor port on there, so we can get a look inside of here and show you exactly what's going on. So I could have sworn years past this little worm drive gear on here was plastic on certain models. It probably is on certain Ford transmissions. But on this one, you can see it looks like it's literally been machined into the tail shaft of the transmission. So it really can't fail unless it's all chewed up, but that looks good to go. And you can see back here where it splines up with the drive shaft that sticks through on the other side. And that's how the connection is made inside of there. So I'll spin the drive shaft real quick, and you can see how it just spins around, and then it runs the vehicle speed sensor and produces a signal. Pretty darn simple. All right, so let's go ahead and test the sensor next. Now, at this point, we know the speedometer in the cluster is probably faulty. I mean, we turned a key on, and the thing blips and freaks out. The guys put it in the drive, I put it in the drive, and it freaks out, not even moving yet. And when we start driving, it kind of just sits there and goes right up to 40 and pegs out and just sits there. So we know we probably have a cluster and speedometer issue. But we still have that noisy vehicle speed sensor signal going to the PCM and speed control servo and also the cluster. So I figured since the aftermarket sensor's out, I figured I'd take a look at it, and we'll do a few basic tests on before we go any further with this, okay? So like I said, the wiring's okay going up. We know the worm drive inside the transmission is good to go. The plastic gear on here is good to go, and the sensor is brand new. It should be good to go. Well, I don't trust aftermarket components one bit, especially electronic components. So let's do a few tests before we get crazy with diagnostics. So this is a basic variable reluctance sensor, VRS sensor. So there's only 2 pins on it, and there's a magnet and coil inside, and it literally, when you spin it, it self-excites and produces AC voltage. No external ground or power required to produce a signal. You just need to spin the shaft and spin it around there. As it builds and breaks inside of there, it will actually collapse and produce voltage inside of there, okay? So the first thing we're going to do is we're going to check that coil inside of there. So we're going to do a basic ohm test on here. Now the Ford spec for this sensor is 170 ohms to 270 ohms, so pretty wide range. And this one's right in the middle. Good to go. So the next thing we can do is we can literally check the output voltage on here. It produces AC voltage, so we're on the AC voltage range on it. We just literally spin it, and we can get a signal. It's definitely producing something, even at lower speeds like this. A little erratic, but it's producing something. So let's go ahead and get and attach a drill to it and get a more consistent speed out of it, so we can see how consistent the signal is. All right, there we go. Looks pretty good and centered. So we'll go ahead, and it kind of dances around a little bit. I'm pretty consistent with the trigger on here. And it seems when we get to higher speeds, as it was on the vehicle, look, it's more consistent. It's a smoother signal. See that? So it's kind of doing the same thing as we're seeing on the scan tool. Now, for the heck of it, because the customer was nice enough to just leave the old sensor in the vehicle, the old Ford sensor from 1998, it's probably still okay. We'll go ahead and we'll do the same thing. And we'll just kind of compare them. So we're going to check ohms on this one, because he changed these before I got to the vehicle. So I'd never tested any of this stuff on the old original sensor. So right there, it's perfectly good to go. All right. So let's do the same thing. Let's make sure it's a good connection on there. Let's check the AC voltage output on here. So this one, I'll try to spline on the center here. Straight as possible. And then we'll try to get a signal. So already at lower speeds, the Ford sensor seems to be way more consistent. It doesn't fluctuate nowhere near as much. I'm going pretty slow right now. I mean, we're talking millivolts. It's jumping around. And same thing, once you get to the higher speeds, it definitely planes out. And it's pretty consistent as long as I keep the drill consistent. And that's kind of the way VRS sensors are. They're less reliable at lower speeds, and they're more reliable at higher speeds, okay? They're more accurate at higher speeds. But none of this really matters one bit, does it? What I want to look at is the actual output coming from these sensors to the PCM. What's the PCM interpreting these signals as? How consistent they are. So let's go over the vehicle, we'll connect it up on there, and we'll see what it is with the drill and this sensor connected to the vehicle harness. And we'll look at the data on the PCM and see what it is seeing for vehicle speed. See how consistent it is, and we'll compare the two. Back underneath the vehicle here, we're going to do the same exact test we just did. We're going to attach the drill to the end of the vehicle speed sensor, and we're going to spin it up and see what the signal is. The difference is we are now connected in to the vehicle's harness. So we're going to see what the PCM is actually seeing for a vehicle speed sensor signal on here, what it interprets the speed is, okay? And we're going to see if this one's erratic and the Ford one is not, or vice versa. The reason why this test is so great is because we're testing the entire harness up to the PCM, and we're testing the PCM's ability to take that raw AC voltage and turn it into a usable vehicle speed sensor signal. So we're checking everything all at once. So what I'm going to do now is I'm going to zoom you in so you guys can see the signal there. There we go. And we have the Aftermarket Napa sensor on here right now. We're going to attach the drill to the end of it here. And we're going to do the same thing. We're going to go at those slow speeds and see how consistent it is. You can see how erratic it is. I mean, it's all over the place. I'm pretty consistent right now with my drill speed. And it's just, this sensor speed is all over the place. You see it right there? How it's just spiking like that. A little faster and more consistent. You can see it's just kind of all over the place, okay? Now, for comparison, we'll throw the old Ford sensor on here from 1998 and see what kind of signal we get out of there. All right, now we'll try the Ford sensor. I have the gear transferred over. So get a nice smooth signal on it. All right, here we go. Much better. Let's go down on lower speed. This is where the other one was kind of jumpy. Look at that. Look at the difference on there. That's the drill doing those dips like that. Look at that signal. Absolutely perfect, no spikes. There you have it. So that just goes to show right there that the aftermarket sensor on there that they were using was causing all those different spikes. So they went after the cluster. They thought the cluster speedometer had an issue because of the signal down below here, but in all reality, it was all based right inside of the cluster. The problem's inside the cluster only, and they actually created a problem by putting on the aftermarket sensor down here and getting that erratic signal on there. So what we're going to do at this point to verify that is we're going to literally install this. Now that's complete, the gear back onto the Ford sensor. We're going to install this inside the transmission, put it all back together, and then we're going to go up top there and see how the cluster responds, and we're going to see what the signal is, of course, on the scan tool. And that'll really verify it right there. Here we go, moment of truth. So we're going to do the same exact test. Key on, it bumps, start it up. Oh, there it goes. See, I told you before, when you start it sometimes it just jumps like that. I mean, in the vehicle speed sense signal, nothing's been happening for a while now. And the thing's just doing anything it wants. So, put in the drive now. We're not moving yet, as you can see here. I'll let my foot off the brake, and we'll just roll it idle here. Jumps right up. Let's check our vehicle speed sensor signal. It ramped right up. And we're just cruising along right now at idle on the lift. And we're doing about 14 miles an hour. Look how clean that signal is. So that right there goes to show it was the aftermarket sensor causing new problems. But again, our original problem, the cluster, is still here. And that's because the cluster itself has failed. What has failed? I don't know. I don't rebuild clusters, but I imagine it's either the pointer on here or the motor inside of that runs the speedometer itself. So, yeah, this was a wild one because the customer or another shop, they got involved first. And I had to think about it and go, aftermarket, I don't trust them. Other shops, I don't trust them. I'm going to start fresh with Diagnostics and go from there. Look at that. It's beautiful. Now, the other thing that I checked before all this is you have to realize this vehicle speed sensor signal, you can see it right there, it comes down and it splices off to a couple different components, okay? So everybody just kind of gets a little taste of the pie. So directly it goes to the PCM. We're looking at that right now. But it also goes to the cluster, which I can't talk to in the scan tool. It's too old of a vehicle. And that branches off to this speed control servo. So at first, the very first thing I did, because it was erratic and it was a new sensor, I eliminated anything else on that circuit that could be acting up. So I went ahead and disconnected the cluster and disconnected the speed control servo. Don't need them. Only thing I could talk to is a PCM anyways. No change, of course. Reconnect the cluster. It's acting erratic. And then I went after the sensor itself, and sure enough, aftermarket for the kill here. So look at that. So at this point, the big problem is it's a 1998. Can we get this cluster repaired? And that's going to be the next challenge. But anyways, I just wanted to bring you guys along for the little diagnostic road trip here. And that's all for now. I'll see you guys next time.